Hi, welcome back. In the previous video, I demonstrated polynomial division using long division. And if you haven't watched that video, I encourage that you do so, because in this video, I'm going to show you kind of a shorthand method of doing this. So there are a couple of caveats with this. I'm going to talk about something called synthetic division. Now, synthetic division presumes that we are dividing by something of the form x minus some constant. Synthetic division only works in this case. The other thing that you must remember in synthetic division, like in long division, is that all powers must be represented. In other words, I'll show you an example here before we're done. But we may have to put in some zero placeholders if we're missing some powers. And this is in the dividend. So in what we are dividing into. Okay. So this is my long division over here. And what I want you to remember is this 1x squared came from asking, what do I multiply by 1x by in order to get 1x to the third? And then I multiplied the x squared through the x minus 2, and that gave me this x to the third minus 2x squared. Now, I then changed its sign so that I could add instead of subtract, because in long division we normally subtract at this stage. Then I added the 2 and the 4 together, and that's where I got this 6x squared from. Now this 6x came from asking myself, what do I multiply 1x by in order to get 6x squared? Okay, so here's how we do synthetic division. Now, synthetic division is always x minus a number. So in this case, we're dividing by x minus 2. And so what we do is we take the x minus 2, but we are only keeping the 2. And I put it in a box. And now I think about my 1x squared plus 1x to the third plus 4x squared minus 5x minus 14. But I'm only going to keep the coefficients. So I've got a 1, a 4, a negative 5, and a negative 14. Now I draw in a line, because I'm going to write some stuff down. Now here's what I do. So down here, so this bottom row here, in this spot here, I'm going to get the coefficients of my quotient. So this will give me my answer. This line is kind of my scratch work. I drop down the first number. So this is a 1. And we'll do a couple more examples, but what we're going to see is that as long as I'm dividing by a 1x something, then this coefficient will always match this coefficient. So now what do I do? Well, now I take my 2 and I multiply it by the number I just wrote down, and I put it in the next available spot. So 2 times 1 is 2. And now I just add. So I get 6. And actually I'm going to use a different color down here. I'm going to use different color. Hold on. Drop down the 1, multiply by the 2, and add it to the 4, we get 6. Now remember, this 6 came from this 4 plus this 2. And as long as this is a 1, this coefficient will always match this number. So now I take my 2 times my 6, and that gives me 12, and I add, and I get 7. Comparing that to my long division, I brought this -5 down. I added to that 12, and where'd that 12 come from? Well, that 12 came from this 6 times this 2, and that gave me 7. And as long as this is a 1, this number will always match this number. Now I multiply my 2 times my 7, and I get 14, and this will always be my remainder, which in this case is indeed 0, indicating that x minus 2 is a factor. So what I've learned here is that my function, x minus 2 times, now this was an x to the third, an x to the squared, and x. And my result will always be 1 degree lower, so this is an x squared plus 6x plus 7. So x minus 2 times x squared plus 6x plus 7 is another way of saying x to the third plus 4x squared minus 5x minus 14. Okay, let's try another one. Let's try one that's slightly more complicated. So there's something else I want to tell you here about this remainder. Yeah. In the textbook, there's a discussion of the remainder theorem, and you should take a look at that. I'm not going to go into that. I want to stick with zeros and factors. So let's consider this. I am told I want to find, let's find or simplify four x to the fourth minus 4x to the third minus 11x squared plus 12x minus 3 divided by x minus 1/2. And in the context of this course, really what this means is we are asking ourselves, is 1/2 a zero of the polynomial 4x to the fourth minus 4x to the third minus 11x squared plus 12x minus 3? So if p of x equals that, 4x to the fourth minus 4x to the third minus 11x squared plus 12x minus 3. And I want to know, is 1/2 a zero? Well, there are a couple ways we could check this. We could just plug it in and see, but we might want to find all the other zeros. So let's divide. So what I want to do is I'm going to do this two ways just to show you that they are equivalent. I'm going to divide x minus 1/2 into 4x to the fourth minus 4x to the third minus 11x squared plus 12x minus 3. Let's just do this polynomial division real quick. So compare x to 4x to the fourth. I need to multiply x by 4x to the third in order to get 4x to the fourth. Now I multiply 4x to the third through by x minus 1/2, and I get 4x to the fourth minus 2x to the third. So I write down here 4x to the fourth minus 2x to the third, and I would subtract, but subtraction just means adding the opposite, so I'm going to just reverse both of those signs so I can add. And I get negative 2x to the third. Now I bring down the 11x squared, and I ask myself, what do I multiply x by in order to get negative 2x to the third? And the answer is negative 2x squared. And I multiply negative 2x squared through x minus 1/2, and I get negative 2x to the third plus x squared. But now I'm subtracting, so I'm going to reverse those signs so that I can add. And that gives me 0x to the third minus 10x squared. Because, whoops, nope, sorry. See, this is why I do that. That's now a minus sign. Negative 11 minus 1 is negative 12x squared. And I bring down the plus 12x. Now I ask myself, what do I need to multiply 1x by in order to get negative 12x to the squared? And the answer is minus 12x. Multiply negative 12x through by x minus 1/2. I get negative 12x plus 6, but I remember I'm subtracting, so I'm going to add the opposite. And that gives me 6x minus 3, multiply through by 6, and I get 6x minus 3, but I'm subtracting, so I'm adding the opposite, which gives me 0. So my result would be, so 4x to the fourth minus 4x to the third minus 11x squared plus 12x minus 3 divided by x minus 1/2 is equal to 4x to the third minus 2x squared minus 12x plus 6. Okay, that's long division. Let's try this with synthetic division. So in synthetic division, we first check to make sure that I've got an x minus a form, and I do. And the a is 1/2. So that is what I put in a box. And then next to that box, I write the coefficients of the polynomial I am dividing into. I draw a line, and now I always start by dropping down the first coefficient. So that's a 4. Now I take 1/2 times 4, and I put that in the next available spot above the line. 1/2 times 4 is 2, and I add. I get negative 2. Now 1/2 times negative 2 is negative 1. And I add. Negative 11 minus 1 is negative 12. 1/2 times negative 12 is negative 6. 12 minus 6 is 6. 1/2 times 6 is 3. Whoops, my apologies. 3. Negative 3 plus 3 is 0, and I put that in a box to remind myself that that is my remainder. And sure enough, I get the same result of 4x to the third minus 2x squared minus 12x plus 6. Okay. Now I promised you one more with missing powers. So let's try one of those. Let's try this. I want to simplify 4x to the third plus 2x minus 3 divided by x minus 3. Okay. So if we're going to do this with long division, we would write down an x minus 3, my division symbol, 4x to the third plus, now I don't have an x squared, so I put in a 0x squared as a placeholder, plus 2x minus 3. My polynomial dividend, the polynomial I'm dividing into, always needs to have all of the powers, starting with the highest one, marching down one power at a time. So if you've got a cubic, you need to have a total of 4 terms underneath this division sign. And now I carry on as usual. So I would multiply x by 4x squared in order to get 4x to the third. Multiply that 4x to the third, x squared through by x minus 3, and I get 4x to the third minus 12x squared. But I'm subtracting, so I'm actually going to add the opposite. And that gives me a 12x squared, and bring down the next term. Now, I ask myself, what do I need to multiply x by in order to get 12x squared? And that would be 12x. Multiply through, we get 12x squared minus 36x. But I'm subtracting, so I add the opposite. And this gives me 38x minus 3. And I ask myself, what do I multiply x by in order to get 38x? And that would be 38, which would give me 38x minus 38 times 3 is 114. But I'm subtracting, so I'm going to add the opposite, which gives me a remainder of 117. Oh, well, okay, so what does that mean? Well, that means that 3 is not a 0 of 4x squared plus 2x minus 3. And in fact, what it means is that we could write 4x squared plus 2x minus 3 as x minus 3 times, 4x to the third plus 2x minus 3 can be rewritten as x minus 3 times 4x squared plus 12x plus 38. But what do I do with that remainder? Well, I add it to 117 divided by whatever we're dividing by. Think about it this way. We know that 5 halves, so 5 divided by 2 is 2 1/2. But we also know that if I take 5 divided by 2, I get a remainder of 1. Same thing, okay? You can always write your polynomial as a divisor times a quotient plus the remainder divided by the divisor. Now this also, though, remember, means that 3 is not a 0 of this polynomial, because x minus 3 is not a factor. of 4x to the third plus 2x minus 3. Because the division did not give us a remainder of 0. And you may be wondering, well, can I still use synthetic division? And the answer is yes, you can. So let's set this up. So I need to check, am I dividing by x minus a number? And I am. And in this case, that number is 3. And so I put in my coefficients, 4x to the third plus 0x squared plus 2x minus 3. And I carry out my synthetic division. So I drop down the 4. 3 times 4 is 12, and I add. 3 times 12 is 36, and I add. 3 times 38, we already discovered was 114, and I just realized I made a mistake because negative 3 plus 114 is 111, and that is my remainder. So this 117 should be 111, and that 117 there should be 111. Okay, there is a lot more information out there available on synthetic division and long division. I urge you to consult your textbook and contact me if you have questions. I hope this has been helpful.